Hello, everyone. My name is Andre. Thank you so much for being here and attending this session. And I want to thank the organizer for giving me this opportunity to talk about the work I did on this new OpenAPI HTTP connector. Um, this is a short session, so I'm going to go through a number of topics very quickly. But if at any point you have questions, please add them to the chat. I'm going to try to cover them as we go. Um, Quick introduction. So my name is Andre. I'm part of the data platform team at Rippling. At Rippling, we use Presto as our main query federation engine with different storage backends. From an overview perspective, the work we do at Rippling as part of the data platform team is to bring all the data across all the different Rippling apps together in order to power applications like reporting and other forms of customer-facing analytics. Um, in order to accomplish that, we developed a DSL called the Rippling Query Language that when a report loads or when you see some other like data visualization within the product, that expression defined as Rippling in this Rippling Query Language gets translated into Presto SQL and then executed accordingly. Before Rippling, I was in a number of technical roles, and in general, I'm really into technology for the kind of like change it can bring in the world, um, and that's keeps me passionate about all of this. Um, a bit of history of like how this project came into being. It largely started as a weekend exploration. I We were chatting, rippling about this problem. How can we deal with queries that are too long because they have to embed data inline? What I mean by inline data, I mean large arrays that are typically used to define permissions. And we are wondering if we can figure out like a mechanism such that Presto, rather than having those constant be defined inline, would reach out to an API to retrieve the relevant values at query evaluation time. When we started to think about this problem, we stumbled across the Presto Thrift connector as a potentially good fit. Um, but it proved to be difficult to build Thrift API endpoints. So we started to explore this option of like, would it be possible to take the same core concept behind the Presto Thrift connector, but have it work over HTTP over a REST API? And this started as an exploration. Let's see if I can. Well, how much progress can I make on this? Just like kind of like hacking over on it over a weekend, and the answer is that it didn't prove that difficult. So this is how this project came to life. Since then, we made a lot more progress towards integrating it in the Rippling stack, and this is now something that we use live in production. Um, just a bit more color around the use case. So as I mentioned, the primary use case that we're tackling here using this connector is rather than inlining a big array of object identifiers, we want to replace that with a read from a table that is accessed using this connector. These large arrays are typically used for permissions at Rippling, and in order to generate them, um, there is complex business logic that needs to be evaluated that cannot easily be translated into SQL. So we absolutely have to call into application code, and we need to find a scalable way of calling into application code. Moving on, what does the connector do? So the main thing that the connector accomplishes is it allows Presto to reach back to a set of APIs defined in a service that implement a spec. And what those APIs allow Presto to do is to retrieve the values for a set of columns. The API, for anyone who previously worked on a Presto plugin, I think you'll be very familiar with the concept because it kind of maps one-to-one to what the service provider interface for creating plugins in Presto provides. Um, and I embedded in line here um, uh, the endpoints to just give you a sense. Basically, the way things are organized is that a service implementing the Presto Open API spec here would be able to expose an arbitrary number of schemas. For each of those schemas, expose tables. Tables can be defined as having multiple splits, and then for every split, a set of rows can be returned back to Presto when evaluating a query. The configuration is very simple. All you have to provide is the base URL where all these endpoints are available and an authentication token. If you go to the README in the GitHub repo, you'll see that there are many more configuration options available that you can use to tweak how the HTTP client works, and also choose from like other authentication options available. Once configured, and before we go there, an implementation, when I say that this allows calling into um, application code, what it really boils down to in the end is that you can have functions defined in any language in the end. I have a few examples here of Python that run application logic, and those will become available as tables. The two examples that I put on the slide here, one is from an example Python implementation that is part of the repo, and it kind of shows how for a schema called virtual, we have a function called permutations that simply calls into the equivalent Python function permutations to give you the permutations of a word. Within Rippling, we fleshed out this framework a little bit more. So we have a decorator-based approach that has an additional set of type checks to make sure that tables are well defined. Um, when so with all this in place, the user experience of using the connector kind of looks like this. It's very much the same as querying any other table from any other connector. But what you get back is the output of evaluating a function. There are a few things worth noting here. On one hand is when you do an equality check, like word equal rocket, that gets translated into a parameter being passed to the function. That condition or word is null is a way to signal that I don't need the value for this column to be returned back, and you should be returned as null. And everything else is like normal Presto business regarding like sorting the results by random value and then fetching just like top 10 results. What's worth noting here is that for this query, while it's only displaying 10 rows, it actually fetched a lot more from the server, or like 363,000 rows in order to produce this result. That means that you can juggle much larger and yet small um, uh, uh, constants or like data structures that you would normally be able to embed in a query, and get things to work for you. That's pretty much it what I had. Thank you for attending this session. If there are any questions, I think we still have like 1 or 2 minutes for that. So feel free to use the chat if that's useful. Cool. I mean, I think that's it then. Thank you all for attending and enjoy the rest of the event.